4.2 Function operations. Here's some notational rules given two functions f and g. Sum and difference, f plus or minus g of x equals f of x plus or minus g of x. Note this is two rules. What I want you to do is write both of them. Try to do it right now before I do it. What this one is saying is f plus g of x equals f of x plus g of x. It also says f minus g of x equals f of x minus g of x. So we put the plus or minus just because it's a compact notation. Next one, this solid circle is the multiplication. So this is going to give us f of x times g of x. Similarly, when you're looking at this one, we'll have f of x over g of x if g of x does not equal 0. Now this is an important thing. Whatever makes the denominator equal to 0, you're going to have to restrict that. So let's say it's at x plus 5, that g was x plus 5, and you plug that in. No matter what f of x is, you would have to say for x not equal to negative 5 if it was x plus 5. In composite, we'll wait on that. What I want to do is draw the graphs of this, and then we'll look at some questions in regards to that. So one thing we can do for this is we're going to look at its domain. Now, how do we start its domain? We did that one before. We look at everything on the inside of it, and we're going to set it greater than or equal to 0. Now this goes back to what we did last chapter. We're going to go 5 minus x, factor it, so we can find the zeros. We'll look at a number line. We have negative 5, 5. Forgot to write my zeros. X equals plus or minus 5. It has degree 2 and it's negative. So we're going down. We have negative, positive, negative. What do we want? We want positive or 0. So therefore we want it from negative 5 to 5. So what we can do now is let's make some table of values here, because we don't really know what this graph is. We haven't graphed it before. We can start off by doing something like negative 5, 0, and 5. Negative 5, we plug it in, we'll get 0. At 0, we'll get 5. And at 5, we'll get 0. It's not going to be enough to plot those points. At this point, it could be an upside down V, although we should recognize that this is not the absolute value graph. So let's plug in some other ones. If you think about it, there's a couple numbers that are nice. One would be negative 3 and negative 4. If you plug in negative 3, we'll have 25 minus 9, which is 16, and that'll give us 4. And if we do plug in negative 4, we'll get 25 minus 16, which is 9. And similarly, if we plug in positive 3 and positive 4, we'll get those same values. Since we're squaring it, the plus or minus doesn't matter. So we can go 3, 4, 4, 3, plot it on the other side, and now connect our dots. What is this graph? It's the top half of a circle. Now let's look at this next one. Let's pick some values in here. We know the basic shape of an absolute value. We looked at that one before. That is going to be a V. Let's pick what are some nice convenient numbers we can pick. Well, we want to pick something that's a multiple of 3, and that way that will reduce. So if we go negative 3, 0, and 3, negative 3 absolute value is 3 times 4/3 gives us 4. 0 would be 0, and then 3 would also give us 4. So let's go 3, 4, we have 0. Now if we take into account what this graph looks like, we should know and say, well, I know what this graph is. This is a V shape. If I plugged in 6, it would be 6 divided by, absolute value of 6 is 6, divided by 3 is 2, times 2 would be 8. And I don't have that quite enough on my paper, but it'd be approximately there. And we can kind of see that we are getting this absolute value graph. So let's do this. should have done is taken out my different colored here. There. So this one is g of x, and the semicircle is f of x. So we have our graph. Now let's answer these questions. First of all, what does this mean? Does this say f plus g times 0? No, we're going back to our function notation, and what that's dealing with is this first sum rule. So it means f of 0 plus g of 0. Now there's a couple ways we can go about doing it. We could just plug it into the equation, but for right now what I want to do is emphasize what's happening in the graph. I want you to be able to see it in the graph. So f of 0 at x equals 0, what is the f value? That's 5. What's the g value? That's 0, so 5 plus 0 is 5. Similarly, we can say f of 3 plus g of 3. So we go over to 3 and say, what's the f value? That's 4. Plus the g value, that's also 4. So that gives us 8. Next one. This means f of x minus g of x equals 0. If we move the g to the other side, we get f of x equals g of x. Now, what does that mean on the graph that f of x equals g of x? That means they cross at those, whatever values they cross at. We want the x values of those intersections. So we can look at that and say, all right, here's one intersection point, and that value is -3 because it's blue, and then the f graph cross. And then at the other side, there's also one. So our answer would be x equals plus or minus 3. If we simplify this, this time we're going to look at where is f bigger than g? Where is f above g? So we want f, we want it to be greater than, we want it to be above the graph of g. So let's look at our graph in here. So where is the f value bigger than the g value? If we're looking at that, if I look at, let's say, this point right here at -4, the blue graph, which is g, is above the f graph. In other words, this y value is bigger than this y value. We had already determined that at -3 and +3 they were equal. So if we look over here and see this section in between, here's a specific example. At x equals 0, we had 5 for f and 0 for g. Well, 5 is bigger than 0. F is bigger than g. In fact, at every single one of these values in between -3 and 3, this f graph is bigger than the g graph. It is above it. And so this answer would be from -3 to 3. Now, what if I asked, where is g bigger than, in fact, we could write this down. We could put a part C, where is g of x greater than f of x? And looking at that one, we would say, oh, this outside part, but you got to remember we only have a domain from -5 to 5 for f of x. So definitely at -5, the blue graph is above, and every other value until we get to -3. So we're going to include -5, and then we're not going to include -3. Why don't we include that? Because at that point, they are the same. And similarly, on the other side, we will have from 3 to +5. And we must include that. We could take a quick second and review our interval notation. This would be -3, 3 in parentheses, and over here would be bracket, -5, -3, parentheses, u, parentheses, 3, 5, bracket. All right, let's take a look at the next side. What I want to do is go back on the other piece of paper and write down what the composite function. Now note this is f composite with g. It's an open circle there. What this means is f of g of x. So there's a couple ways to write it in terms of talking about the domain. I want to say the domain is the intersection of the domain of g of x and the domain of the simplified f of g of x, i.e., in other words, where the two domains overlap, where they intersect. So now what's important about g in this setup? G is our inside function. So in general, it is the domain of the inside function intersection with the simplified form of f of g. Let's look at a specific example here. So first, if we want to find, oh, I should have written it as f composite with g to simplify to this. What is g of x? G of x is the square root, so we're going to look at the square root of x, and then we'll say the square root of x squared minus 1, and that simplifies to x minus 1. Now let's find the domain. Well, how do you find the domain? We need to first find the domain of the inside function. What's this inside function? G. Well, that's our square root. The domain is x is greater than or equal to 0. What's the domain of the simplified? That's just a line, so that's going to be all real numbers. Where do those two things overlap? They're going to overlap, well, if this is greater than or equal to 0 and this is all real numbers, if I was looking at a number line, all real numbers is everything, and greater than or equal to 0 would be there. Where do they overlap? Greater than or equal to 0. So our domain here is x is greater than or equal to 0, and as a review, we could write this as x such that x is greater than or equal to 0. Now what about our range? Well, remember I said when we have a restricted domain, we want to look at that restriction, and that will help us deal with this range. As x is going to 0, what is this value going to? That value goes to negative 1. And let's take a look at it. That's a line, and it looks like x has a y-intercept of negative 1. I'm going to put that second part dotted. Why am I going to do it dotted? Because the only place I care about, just like when we were talking about piecewise function, is from the y-axis on, from x equals 0 on. So my range is going to be, well, what are those y values? Those y values start at negative 1 and they go up forever. So y is greater than or equal to negative 1. G of f of x, so that's going to be g of x squared minus 1. So if you want, we can start talking about the domain of this part immediately. What's the domain there? There's no restriction when you square something, so it's just all real numbers. Now let's plug it in. For f of x, so f of x is, or g of x, sorry, g of x is our square root, so it's going to be the square root of x squared minus 1. How do I find the domain of that? Remember, this is a square root. We can only take the square root of positive numbers are 0, so we go x squared minus 1 is greater than or equal to 0. Factor that. This type of problem is going to occur often, so you want to make sure that you're comfortable with it. This goes back to what we've done with in chapter 2 or chapter 3 with graphing inequalities. What's our degree? It's 2. Is this positive or negative? It's positive. So we have positive, negative, positive. What do we want? We want the positive or 0. So in this case, we want from x is less than or equal to negative 1 or x is greater than or equal to 1. Now on this one, I'm going to bypass finding, actually I'll just show you quickly. On the range, this one's a little bit harder. If I go to 0, as x goes to 0, or x goes to 1, what does this value go to? And we can just, for right now, we can think of it as x equals 1. Then the y would equal 0. As x gets big, as x goes to infinity, what does y happen to y? Well, if we get a bigger and bigger number, we square it and we subtract 1, the 1 really isn't having any effect. And then so this is just going to be the square root of x squared. Well, as x gets big, y is getting big. Can you ever take and get a result, take the square root of a number and get a negative number out? No. Not for when you're taking the square root of real numbers. And so our range here will be y such that y is greater than or equal to 0. As far as a range goes, that's a harder one. And then let me write our answer for our x as well. And that's it.